Alright, this is Angelica Madsen's test corrections for test 2. So here's my test. The first question I got wrong was question 3. Question 3 says a mass M is pulling along a rough table at a constant velocity and with an external force at some angle above the horizontal. And then it gives us this body diagram, and I said the correct answer was C. Here's my little explanation. The real correct answer is the friction force is less than the external force, and the normal force is less than mg. So what that is, it's shown here. So we know that the friction force, the correct answer, the friction force is supposed to be less than the external force. And that is because if the friction force was if it was equal to the external force, then there would be no movement. And if friction was greater than the external force, then friction would cause it to go the other way, which doesn't even make sense. So in other words, if we want it to have a constant velocity going in the direction of the external force needs to be greater. And that is why the correct answer is B. For the next problem, problem number 4, it's talking about a car going around a circular curve on a road. The correct answer is C, and that is the frictional force of the road on the car increases when the car's speed increases. What I said is the frictional force of the road on the car increases when the car's speed increases. And this is because the friction has to increase as well, or the car will slip. So a faster speed requires a larger net force towards the center. The radial component of the static friction adds to an R to allow the car to make the turn. And obviously there would be a point where the car is going too fast along the turn and it will slip. But until it hits that point, friction will increase as the car's speed increases. And then the next problem, problem 6, let me turn the page. Problem 6 is about a ball that is suspended on a string, and a charge rod is brought near the ball and causes force on it, causing the ball to swing out to a 21-degree angle. Basically, how I did it, I kind of did it right. I had kind of the right components here for the angles and everything, but I just didn't quite get there. So when you do all the math correctly, this is what it looks like for problem number 6. So you're able to do those formulas, which I got right on the test, but I just solved for the wrong stuff. So you needed the net force, so the force of that component plus the gravity component, and it has to equal 0. So if you set it to 0 for the vertical and for the horizontal, and then you solve for the forces, and then you eventually, so these are the equations I wrote on my test, and then these are me applying them, and then I solved for tension and all this jazz, which leads you to the right answer. I just didn't quite solve the right equation on my test. And then for question number 7 is about a roller coaster car that goes over a hill with the radius as 15 meters, and the mass is 500 kilograms, and the track exerts a normal force of 3,300 newtons on the car. So I drew a little diagram on my test, and here's the little car going over the curve. And I kind of had sort of a right idea, but I don't know why I started using orbit. This is obviously not an orbit problem. But how I solved it correctly is so I wrote down all of what we know, and then I was able to use this equation for velocity, and I plugged everything in, and I got velocity is equal to 7.7 meters per second. And then the next question that I did was problem number 10. So problem number 10 is about a crate, and it is being pushed at a speed, initial speed, going up this 15-degree incline, and then it eventually slows to a stop, and then we're just supposed to find what the coefficient of friction is of the crate going up the hill. So what I did on my test, I didn't do really anything except for I drew the picture and wrote what we knew. So how to solve the problem is, initially what I did is I solved for, let's see, yeah, I used the kinematics and I solved for my acceleration, which we know the acceleration is pointing towards the left because because the crate slows to a stop and accelerates in the downward direction. So it is a negative acceleration, that is why. And then I was able to plug in net force is equal to MA, so MA is equal to the coefficient, mass times gravity, and then all that jazz. And then you solve for the mu, which is what the coefficient of friction, that's the symbol for it. So then when you solve it and you plug in the acceleration and all this jazz, which is the x and the y components based on the angle of the crate to the ramp, and we get 0.14 as our answer. Alright, so the next problem that I decided to do is problem number 11. And this one is a medium-sized jet with a fuselage and all this jazz going on. You can read it yourself. But we're basically calculating how much thrust the engines need to provide to be able to cruise at 230 meters per second. And it gives us the density, the drag coefficient, the mass, and the diameter of the fuselage. And so to do the problem, so I wrote down all of the information that we know, and then you just use the drag equation. And that's 1/2 CPAV, where C is going to be the coefficient of drag, P is the the density, and A is the area, and the volume is V. So we plugged in everything that we knew, and I calculated the area because it gave us the diameter, and it said that it was a cylinder, and you're only supposed to base the area on what the front of the object is, because that's the only part of the object that's going to put up air resistance and the drag, obviously. So we just did the circle, which would be the front of the fuselage, and so that was pi r squared, and by doing that we got the 11.34. So I plugged all of that in, and I got the 1.1 times 10 to the 5th newtons. Alright, and that is all I did for Chapter 2's test corrections for physics.